Welcome to Middle School Physics Episode 2. Oh, my hair is really messed up. Today we'll be talking about not just units, but SI unit conversions. We already talked about units a bit in the last video. The last video was a complete fiasco. It was just a mess. I just wanted to see if people really enjoyed it, if I enjoyed it, if I could actually take this thing seriously, how to screw around with this little sketch pad that I have to see if I have the ability to do this, if I have the time, if I have the equipment to do this, and I've enjoyed it. I like helping people out. I like remembering 6th grade physics, and it's fun doing it in a video format. So I have gotten a new email address. This is actually wrong. It should say middleschoolphysicshelp@gmail.com. So this should say help. Anyways, just look in the description if you want the right email address, because my writing is horrendous as always. So in the description, I'll have my right email address. The website will come soon if I don't procrastinate. Not likely. I'm just kidding. It'll come in hopefully a week or two. I just need to find more practice problems. It's taking me a lot of time just to make the first couple of pages. So it takes a lot of effort. I have to plan everything out and we'll see what happens. So let me disappear real quickly and let's dive straight into the lesson. So for unit conversions, we use SI units. So remember, like last video, I'm pretty sure I've said this. If not, these are the units that we need to know for all of this year. Go ahead and star these 7. Make a big star for each one. Do whatever helps you. You can indent it, you can bold it, you can italicize it. Whatever helps you. You could even draw this wormy figure. I'm sorry, I just wanted to play around with this worm. You can do anything that helps you remember it, as long as you remember it. You will have to memorize them, but you'll do so many practice problems that it'll come to you naturally. You won't have to make like flashcards and memorize them, stick them in the back of your head. It'll automatically be there. It'll come with just practice. So, when we do convert our SI units, hopefully you're taking notes on this, we must use SI prefixes. Now, what the heck are SI prefixes? An SI prefix is a prefix that precedes a basic unit of measure to indicate a multiple or fraction of the unit.
What is that? What is that?
Exactly. What the heck does that mean? This is fluffier than cotton candy. Cotton candy, delicious. Sorry, focus. It's really wordy. There's so many unnecessary words in this. This is actually a quite simplistic definition, but if you're taking this video before the 6th grade, which I recommend doing because it's nice to learn things before you're in that grade, you're spitting out more than 3 words at a time. Like, I can't comprehend this so quickly. So let's go ahead and simplify this. This is a skill that I still need to practice on, and all of us must use throughout our entire education. We have to be able to put things in our own words. This helps us when we take notes, it helps us retain information, and all in all, it just makes things fun. So if I wanted to remember a definition, I just have to make let's call it a unique comparison, and it helps me remember it much better. Much better. Yeah, what the heck. I failed English anyways. So, an SI prefix is a prefix that precedes. Precedes just means to go before. A basic unit of measure. This case, a basic unit of measure would be our unit. Like, would it be in length in meters? Would it be in length centimeters? That's where our prefixes play. You always wonder where centi comes from? It comes from there. To indicate a multiple or fraction of the unit. That just means it's indicating a part that's bigger or smaller than the unit itself. So, an example of a prefix, actually, all of these would be prefixes. Now, you would see these written as, here, let me see. You would see them written as oh, this is so awkward. Centimeters. So in this case, centi is our prefix, and meters is our unit. The prefix is indicating a fraction of meters, indicating that the meter is smaller than its base unit. So hopefully that cleared it up just a bit. So the next time you see something complicated, I will on purpose throw in some complicated, complicated definitions, just so you guys learn how to simplify them, defluff them, like that cotton candy. So let's go ahead and practice our conversions. Whenever we convert our units, we use something called unit multipliers. Now, what are unit multipliers? This one was a non-fluffy definition because I wanted to make it a bit easier. I really like this definition. It's simple and straight to the point. Unit multipliers are fractions that equal 1. The difference between ordinary fractions that equal 1 and unit multipliers is that unit multipliers require unit. Quite self-explanatory. So let me disappear here to get me more space so I can explain this. So what that means is it's a fraction that equals 1. There are hundreds of examples. I'm going to give a couple of common ones. 12 inches is equal to 1 foot. So this still equals 1. It still equals 1 foot. It's just telling us that we need units. The only difference is that now we need units for both ends, for the numerator and denominator. So that's what we use unit multipliers for. So I'm going to teach you how to set up the unit multipliers in our equation. Let's go. So without even looking at the chart, we know that I first have to write 300 grams. Like in every fraction that equals a whole number, if we were to write something like 5 over 1, we know this is just equivalent to 5. So the 1 isn't really necessary. They're both equivalent to the same thing. But I really like writing the 1 underneath just because it helps me clear my thoughts in a way. It feels more organized. So we're going from 300 grams to kilograms. Let's take a look at our chart here. So grams should be written right here. Let me go ahead and do a different color really quickly. Grams should be written in this little box. This is a nice color. This area over here. Now, where is kilo? Kilo is over here. Since we're going down turntable to up, that means our number will end up decreasing. So we automatically know that we have to draw a division sign. So it's known as a fraction of the unit, as we saw in our first definition. So that gives you a little insight on what that means. It's making it smaller. So we automatically know that our units will have to be grams down here. Because remember our unit multipliers. 12 inches, 1 foot is the same as 1 foot. So if these guys were to cancel out, what would we get left with? 12 inches. So we automatically know that we'll have grams down here. So it's just, once you've gone used to the formula and done lots of practice problems, you can clue in little things like that help you speed it up. We'll draw the fraction bar here. Now, what would we do here? So we automatically know, since the denominator is holding the place for grams, the numerator must have kilograms in it. Perfect. Our units are now done. Now we just have to get the values. So let's go to our chart. If you notice, on the side, there's little powers. So kilo is 1e plus 3. That just means 1 to the third power. 1 to the third power is equal to 1,000th of a number. So it's quite simple for us, especially when they're in little bunches of 3s, to understand what our answer would be. Because all we have to do is move the decimal point 3 places. Either we could move the decimal point 3 places, or we could just say 1,000 kilograms. Because 1 to the third is just equivalent to 1,000 in different factors. We just have to use different numbers. So, since we're dividing, 1 would go at the top. Next, we would cancel out each of our units. So in this case, our units grams have canceled out. Then we would divide. This is quite simple. It's just mental math. So we'd go 1, 2, 3. We'd end up with 0.3, and then carry over the units, 0.3 kilograms. So that's our first question. That was a pretty easy one. Let's go ahead and do the other one. So this problem is the exact same. We're just going up by 1,000. So I'm not going to explain it. I'm just going to do it.
Just do it!
So as for the problem, I've already done it. I'm just going to walk you through without having to make any pen strokes, which just makes it a lot easier for me. Oop, what did I just do there? So again, 3 meters over 1 multiplied, since we're getting bigger in this case from meters to millimeters, times 1 meter. There's one thing I didn't add here, the meters crossing out. That's a habit that I'm reluctant to do, and that's a habit that I'm trying to change because it will punish me quite soon. So that's how we do. We end up with millimeters. We multiply that. Again, quite simple. 3,000 millimeters is our final answer. Everything looks a-okay. Now let's go to the next and final question. So we're on now to the last one. It's an interesting one, I guess I would call it, because I'm a geek. Cue the bad cry. So let's stop whining and let's get straight into this problem. We've got to be a bit serious, so I've removed the meme, also for the fact that I'm going to need more space to do this one. Or will I? So there are multiple ways of doing this huge problem. Again, we're going from micro all the way to our base unit. I drew a little diagram here. Whoop. Ignore the purple, just look at the black, not this black, that black. I need to find a better sketch pad, but for now this works. So either we can go from micro and transfer it to milli, milli to centi, centi to deci, then deci to our meters. But there's a better way of doing this. We can go micro to micro all the way to deci, so from micro to deci, and then deci to meters. Now, most physics teachers would agree, okay, that's the base one, that's the most simple way you would do it. But I'm different. Since I'm a kid, I've learned different shortcuts. Now, people have a negative connotation for the word shortcut. I do too, but it depends on what case you're using it in. It can also be a shortcut if you're not skipping any of the learning, you're just finding a simpler way of doing it. If you find your own way to do a problem, and it works every time, and you find it more comfortable, and you can back it up using the knowledge of the standard procedures, then by all means, go for it. I've done this for all of the 6th grade, no problems, just swift through. So what is my method? Let me go ahead and teach you. So earlier I was telling you about the, what do they call powers. So this is e to the 6th, e to the negative 6th, pardon me. So we can imagine that, 1 to the negative 6th. Now, to the 6th power is equivalent to 100,000. Let's go. You can envision it like that. There's no written thing saying, okay, 1 to the negative 6th is equal to, or negative 100,000. It's not like that. I've just thought of this on my own. So let's go ahead and erase that. So, how many powers is that? 6. So we know if we move 1, 2, 3, 4, 5, 6, we end up with 100,000. So that's how I come up with that number. Now, how is that going to help us with our conversion? So let's go ahead and first set this up. My handwriting is extremely bad. I have to find, again, a new sketch pad or something. We just have to find a better form of doing it. And remember that this is the unit for micrometers. It's called the mu. It's an ancient Greek symbol. Go ahead and Google that. It's pretty cool. I like it. Over 1 times micrometers over what? And instead of going decimeters, again, I'm telling you, we're going directly to meters. So how many micrometers in 1 meter? So we just established that from here to our base unit is 10 to the negative 6th, or 100,000, negative 100,000. So all we have to do here is write 100,000. Again, that should be here. And that equals to 1 meter. Cross out our units, divide, again move the decimal place back 6, 1, 2, 3, 4, 5, 6. So our decimal place would be here. And let me go ahead and write the answer in a different color because I'm tired of the same color again and again. 1.99867 micrometers. As simple as that. It was perfectly fine. We got the right answer, and it was quite easy. Everything was beautiful, other than my handwriting. Thank you so much for watching this video. I hope it helped you. Go ahead and try and do some more problems on your own. Until then, don't go changing. Sayonara.